Good afternoon. Thanks for being here. My talk today is about using artificial intelligence to detect threats without decryption. My name is Sunil Ameen. I'm a principal engineer for Cisco within the security business unit and specifically within our advanced threat R&D function. A bit about my background. I've been working in and around security for about 20 years. More recently, I was with a startup that was then acquired by Cisco called Lancope, which produced a product called StealthWatch. I was the chief scientist at the time of acquisition, which was about 3 years ago. And combined with all that experience in the analysis of network telemetry, combined with the research teams that I got to meet at Cisco, we were able to develop this solution. As a kind of an agenda, I want to frame the challenge, the problem we were trying to solve, talk through some of the research items that we completed along the journey, and then actually talk about the solution. And then finally, I want to talk a little bit about some key takeaways, not just about our solution, but any solutions that claim some of these words in the title, because not all things are created equally, and I want to arm you with enough information that you can go and ask the right questions of your vendor or solutions provider. So first up, framing the challenge. This is a timeline of kind of important events in the public sector encryption world over 2018. We've got an updated slide. Marketing promised me one for 19, but basically these are the big events that have ushered in this new era of the use of encryption just everywhere we go. Specifically, this talks about browser adoption, server-side software adoption, as well as standardizations. Everything from TLS, the newest versions of TLS, to things like QUIC being standardized as the HTTP, the next generation of HTTP. All of these present unique challenges in the security cyber threat detection area, specifically making certain features that we would inspect now opaque. Every one of these technologies has a different thing which is hidden for very good reasons, and this presents a challenge for us. This is kind of the same data, but in another format. Again, this is January 19, so that you can imagine the numbers are actually more enlarged at this point in time, but specifically about how browsers and server-side software is being changed or it's standardizing around certain protocols. On the left-hand side, TLS 1.3 sticks out on the browser side, and on the right-hand side, HTTP 2 on the server side, but we're even seeing the servers now picking up TLS 1.3 as defaults as well. So all in all, it's a good thing. We want privacy. We want our exchanges over the internet or whatever network we're using to be private in a way that is appropriate for our use and protects the legitimate use of those networks from snooping and interception. These are all good things. The real problem is that same capability is afforded to the bad guy. Again, the slide is a bit dated and the marketing numbers are a bit obscured here, but let me just give you the breakdown here. Cisco collects malware samples and has been doing so for many, many years. We have a repository of literally millions of them coming through our ThreatGrid sandbox product, and we now analyze that data set on a periodic basis to see patterns within the malware. The pattern here is clear. It's supposed to be a line that shows the increased use of encrypted channels in malware's command and control. So that same protection that we afforded ourselves by making encryption easy, by making these efficient protocols over the internet easy, are now afforded to the attacker. In fact, it's sheer laziness is the only reason an attacker would never use an encrypted channel. So to that point, the challenge, encryption is a double-edged sword. We want it because we want to keep our legitimate use of the network private and out of the hands of an infiltrator. But the security measures that we traditionally use, which rely on inspection, cannot be used, and the attacker could use the encryption in the same way as we do. From a monitoring perspective, you want to ask yourself these two questions. Is the privacy we've afforded our communications adequate? Are we using weak ciphers? Are they up to standard? And on the security side, can we detect threats within those encrypted channels? And that was the basis for the research that a couple of teams within Cisco then started. The goal was what is now called this solution called Cisco Encrypted Traffic Analytics. It's essentially the ability to ensure privacy and detect threats in encrypted channels without breaking the encryption, without decryption. And it all started back in 2016 with this paper which was published by a couple of my colleagues David McGrew is actually a fellow at Cisco and has been working on encryption for decades. But this diagram gives you kind of the very summarized version of what's in this paper, which is basically using that database of malware that we've been collecting, extracting the features from it that represent the types of encryption and encryption and algorithms used in the channels, and using supervised machine learning to train classifiers. If you don't know much about machine learning and supervised learning, it's simply the case of showing a piece of software negative and positive examples of the thing you want to detect. So on the left here, you showed a bunch of traffic that you knew was bad from our malware samples, and then a bunch of traffic which we knew were benign from our LAN network, and allow the software to learn those patterns. You can then apply that software out in the wild to make that determination. Is this benign or malicious? In the paper, they got a lot of success, but as with any outcome when it comes to security and AI and ML, there's a couple of things you need to be aware of. First is the telemetry, the input into the system. What is it that is new and special or different or the same as all the telemetry we're currently collecting that allows us to do this? And secondly, really only secondarily, is the actual analysis, the machine learning classifier design. I'm not a mathematician, so I'm not going to go a lot into the classifier design. If you're that way inclined, the paper is referenced here, and you can go take a look at it. What I am going to concentrate on is the telemetry, and that's really one of the parts of the solution that really is new. Just getting data out of the network in the way we have done so in the past wasn't sufficient, especially at scale. We could, of course, collect every packet, but that's got a lot of encrypted payload, which is basically useless to us. So what we came up with in our design, in the research, was a design for a couple of telemetry data points that we can include in things like NetFlow and IPFix, standard network monitoring systems, to help us do this analysis. The very first one is the initial data packet on the far left, and that's exactly, the name describes it perfectly. It is the initial packet in each direction of a communication transfer, and it is only the first packet. The rest of it's pretty useless if it's an encrypted channel. However, every encrypted channel starts unencrypted, and that IDP will capture that unencrypted part of the conversation. And that's the call setup. That's the cipher exchange, what the server can do, what the client can do in negotiating to something that they can both agree on. Now, that's all in clear and gives us a lot of indications about what's about to come next. And we found a high correlation between the combinations of things in the handshake with the way the actual communication then unfolded. The second thing is the sequence of packet lengths and time. This is a mouthful. It's a derived thing. It isn't even observed straight out the stream. It is kind of a derivative. So as the name suggests, we can look at all the packets that are transferred in this exchange, look at the sizes and the inter-packet timing, and use those as yet another feature to help us work out what's going to happen next. This is, of course, there because inspection of the packet contents is fairly useless in the encrypted world. The final thing, which is not in the paper but is an additional piece of research that is actually in production for us now, is this thing called a global risk map. And that's taking a look at these data features at a global scale, looking at it not just for an individual customer or environment or even a vertical set of environments, but actually looking across all the customers who are willing to submit their data to us. And we can get this a few ways. So what we're able to do is take those data features, correlate them against all the things we're collecting from other products, as well as our own native threat intelligence, and actually come up with this kind of map of the underside of the internet. It's constantly changing. It is machine updated. This is not a human-driven exercise, but it's the long-term memory of our analysis. It's saying where we've seen it bad in the past, how that bad is changing, and where we predict bad will be in the future, again, based on those data features. For Cisco, the reason this is important to us is those data features can be baked into our networking gear, so you don't need an additional piece of equipment to get at this data in order to do the analysis that I'm talking about. Just kind of a reminder of kind of a deep dive into the IDP, the initial data packet. This is, of course, the TLS decomposition of the IDP, but of course, it's just as useful for unencrypted traffic and even traffic is encrypted but not using TLS. And here's a pictorial representation of the SPLT. Again, the interesting thing is our research indicates that there are definite patterns that can be correlated with benign and malicious pieces of software when you look at those times and the packet sizes. All of this is wrapped into those papers as well as some open source, so I encourage you to go take a look at this if you're so inclined. It's called Joy. It's out there on GitHub, and that really works through in real life software the kind of concepts in the papers. Getting to the solution, though, was a little harder, an actual solution that we could productize. That's the research, and I want to put a box around that, and that proved the efficacy of those data points and the analysis that we can do with it. But in reality, we publicized all this. So from an attacker's perspective, they now have the evasion techniques to apply to combat it. And so what we did was actually add this capability to a series of things that we've been researching and developing for many years now, and that's this multi-layer analytical pipeline. So in each layer of the pipeline, we reduce the data, classify, and try to identify the incidents, and then try and explain the incidents. And ETA is actually just one piece of this. The outcome at the end may or may not have used the ETA data fields, but we combine a lot of things together to make it happen. Interesting thing here is that when it comes to machine learning, we run the gamut of techniques that we apply, because what we found in practice, if you rely too much on any one technique, it is available. One of the things that you can do with the solution, which requires no machine learning whatsoever, and sometimes we forget about the easy things we can do with data, is simply ask how much of my business is in the clear versus encrypted, and on the encrypted side, what versions are they using, and are they compliant with any standards we might have? As you could probably manage based on the data, no machine learning here, just simply run a report and say, and kind of look through the communications that aren't encrypted or are using weak ciphers or weak versions that we don't want on our networks. So just the sidebar to say, it's not all about machine learning. We can do some just good old-fashioned data mining here as well. As far as measuring success is concerned, this is a big thing when it comes to any analytic technique, machine learning or otherwise. There are lots and lots of measures. There are lots of measures we can use, mathematical measures. Again, in our experience over the last decade of doing this and putting this in production, there really is only one clear alert, and that was this helpful. It is super subjective, but really is the only way for our customers or our users to feedback whether or not we're doing the right thing. Different people want different things from different alerts, but no one wants a lot of things that they have to go chase down. So when it comes to machine learning and AI, I encourage you also to look at the measures you're using for success. We have found this one in particular to be the one that we've keyed on and enjoyed success with. It literally is a pop-up. Every time we say something bad has happened, the user is asked to click if they found this helpful or not. Really subjective, but has really driven some really great improvements in our products. Here's some track record. We actually track these very, very closely, and we've been able to track close to 95% quarter over quarter. The last thing I wanted to get to, and I've gone very quickly because 15 minutes fly really fast, is some things you want to ask your vendors, including Cisco and ourselves, anytime you evaluate kind of solutions like this, especially when the words machine learning and artificial intelligence are used. The first thing is, how are you applying machine learning in the product, and why? The why being really important. I mean, we can't apply these techniques to all things because this doesn't necessarily make all things better. And then how do you measure its effectiveness? Explain how we do, but others have other techniques, and you want to evaluate not just the metrics they're giving you, but how they produce those metrics. The second thing is regarding supervised learning, what are you using for ground truth? In that training process, you explicitly have to state to the software what is truth. Where are you getting that truth from? We have access to millions of samples of malware, so that's what we use for our ground truth. But is that all-inclusive? Is that exhaustive? Is it biased? And that's something you need to ask of any system that you're using that claims to use these techniques. If non-machine learning techniques are used, why? It's very useful to not use machine learning techniques, but they have their time and the place. And then finally, kind of on the public side, what open source or published papers do you have to prove not supposed to prove, but to show your techniques to the public and open to peer review. And that's something very important for us to do, that we do regularly through published papers and open source. And I encourage to ask any solution vendor the same questions. And finally, for any ML predictions or assertions, what entailment are you providing? Just a big button that says bad and no reason why is not particularly helpful to anyone. To learn more about ETA, go check out this URL and feel free to contact me directly if you have any questions. Thank you very much.
Well, good afternoon. My name is Shane Clark. I'm a scientist with BAE Systems Fast Labs, and I'm thankful you all could be here to see this, and I'm thankful I could be here because I just got into town 90 minutes ago. There were thunderstorms all over the East Coast, apparently, and I guess that delays flights. So it just really shows the requirement or the necessity, I think, of having a robust network, which is robust against having link and node loss and able to reconfigure, which is something that the solution I'll talk about today will help to facilitate. Which is namely Converged RF Systems, specifically Converged EW Systems, if in the near future, which we see is a multifunction hardware providing a force multiplication at a low swap cost. So today I'll be talking about the context and the motivation for these converged EW and eventually RF systems and the benefits of those converged systems. The benefits are numerous, and this is somewhat projecting into the future, but a specific multifunction system or family of such systems exists today at the low TRL level, and we're developing them. I'll talk about one of them, the MMFA ECM, go over just a general overview of some of the technique flexibility in the hardware, the core functionality that provides, including element-level digitization, providing digital beamforming, simultaneous transmit and receive, as well as some of the multifunctionality that we've demonstrated in flight test up till now, and then I'll conclude. So the contextual needs for EW architectures, as we see it, are many, and they reach across a whole host of different areas. So first, they're structural. As warfighting becomes more distributed, multi-platform with networked groups working together, we need to have this ability to network across platforms to share information. Simultaneously, we're also working towards disposable and attritable systems, which obviously puts very large swap-C restrictions on the platforms that are going to be used for that goal. And the battlefield that has to maintain its functionality in a hostile environment. And the tasking demands for resource is generally only going to increase once that resource has been fielded and the needs are ever present. Also, development increases the capabilities as technology marches along, and we try to put smaller and smaller platforms filling larger roles. In addition, we've had a push towards open architecture in EW and looking to save a lot of the redundancies which are created by the former paradigm of these stovepipe systems. So there's a lot of areas there, and it kind of touches on most of the letters of .mlpf, but I like to think of it maybe more allegorically anyway, in context of, say, the development and the usage of flight in World War I. So flight was developed a decade or so before, and starting off, at least apocryphally, the scouters were waving at each other when they were flying over and serving as spotters for artillery. And then they were throwing bricks at each other, and then they were firing at each other with dual 30 caliber machine guns. And so you see the scope creep as once that platform's up there and has the utility that was envisioned, then it starts becoming used for other things, and of course it's vulnerable. And that's the other primary driving force we see pushing towards converged EW systems, which is every platform is dual function. It has to survive, and it has to do its mission. And so using ECM as a launching point towards a converged RF system seems to make a lot of sense to us, because it obviously provides the ability for self-protect and improving the capability of the system to execute its mission. So some of those specific benefits provided by EW architectures, they're found across a number of levels, but at the battlefield level we have the low swap-C requirements that the system requires to perform multiple functions, and to be agile in those functions, to be able to increase in the functions that it performs, so you can add capability without adding weight. It's a force multiplier for the group, as, say, an EA drone is capable of deploying, and then SIGINT techniques or vice versa, depending on the changing landscape, the changing dynamics of the engagement. It also means, because the in-situ assets can be dynamically retasked, the whole organization, the whole group, is more adaptable, more capable, and consequently also more robust, as they're capable of responding to attrition through kinetic or just various electromagnetic techniques, denying the usage of various assets in that network. Further benefits exist at the organizational level. With a converged ECM system, then you have the ability to use common hardware, which is obviously going to give you essentially that open architecture and all the benefits that come from that, and reduce maintenance, logistics, and training costs and so forth because of the reduction in the number of unique systems and unique parts which are needed to maintain and to be trained on to run the systems. In the ideal case, as we move more and more towards converged, we'll see a shift in the development cycle from hardware procurement and development more towards software-defined behavior, where the speed of things moves away from the slow hardware side up towards something more like app development or software updating. This obviously reduces cost, reduces cycle time, which together mean that the OODA loop for new functionality is reduced, and we're able to maintain or increase our advantage against near-peer adversaries. So the functionality is useful. The hardware and the system, which must be designed in order to provide this functionality to the warfighter, is exemplified in one of the systems which we are building in this matrix-based multifunction array family, essentially. This is the ECM system in that family. This is an integrated multifunction ECM system, and it's modular, but it hosts a number of capabilities which are required for next-generation ECM. We have digital beamforming, which provides multiple digital beams to be generated simultaneously. It also is capable of simultaneous transmit and receive, which is a requirement for multifunctional systems. You can see up front there, you can see the laser. The radiator and the aperture is essentially a modular, just like the rest of it. Can be swapped out depending on platform needs, even system needs if needed. And the number of modules is reconfigurable depending on the platform, available swap-C requirements, that sort of thing. And I'll put together the functionality of this is that it's functionally agnostic. This is designed for ECM, but it can perform other roles. It also is platform agnostic, and the core technology is extremely scalable. And we'll see that here, where one 8-channel module could be used on, say, an air-launched effect, very small-scale drone. But then multiple modules can be used in conjunction to provide functionality at larger platforms, moving up through class 2, 3 UAVs and larger. These can be deployed as part of a phased array or individual antennas. So again, the aperture and the number of modules is then configurable at the platform level so that this same system is essentially converged across a number of different platforms. So the core technology in that module and enabling this system is the Matrix, which is an RF FPGA, a reconfigurable fabric of microwave and radio frequency blocks, 2 configurable frequency generators in there. And this enables rapid rearrangements of the configuration of our RF front end in this system in the field, enabling frequency flexibility and then ultimately that functional flexibility as well. Extremely fast in its changes, fast hopping between CFGs and then coherent phase hopping as well, useful for a number of techniques. Another feature of the MMFA is simultaneous transmit and receive, or STAR. This is essential for this multifunctional system because we can perform various functions, and if we're jamming or something, still maintain the functionality that we were exhibiting in some other area simultaneously. So it's capable of same element, same frequency, STAR. This is provided both through an analog front end and then digital compensation on the back end. In addition to that, because it is such a flexible system, if the requirements for some given engagement or function were to exceed what the STAR sensitivity and isolation is capable of, then the multifunctionality and the reconfigurability of the system comes into play, and additional layers of isolation are able to be added in between transmit and receive, including polarization isolation or even spatial separation across the face of the aperture. And that's enabled because of the element-level digitization, because we have each element, each channel is controlled and going through one of these matrix RF FPGAs. then we can control the aperture and the usage of not just the array, but of the various arbitrary subarrays which we can form on the fly. So you see here we have two different epochs, starting off here with an LPI COM link, maintaining situational awareness down at the bottom there across the spectrum while engaging in LPI comms, and then turning the rest of the elements off for power savings, ensuring flight time or whatever else the case may be. Then, as things change, all of a sudden, it's gone hot, and we can have multiple simultaneous jamming engagements that the aperture is now engaged in while working on MTI radar, and still maintaining the LPI link and the situational awareness with the steering receivers. And so this is the capability that we see in time with this multifunctionality, that it can trade power or functionality, and it can work between different functions simultaneously, making those trades on the fly as needed. This will be demonstrated in 2022 with the TRL-6 flight demo, shown here providing self-protection while communicating with an ALE or ALE stand-in while engaging in Doppler radar collection of a ground vehicle. And this is obviously in the future, but it's not just vaporware. We have demonstrated the core technology of this as part of the DARPA Concerto program on TRL level 4, flight testing both the core hardware, the matrix-based radio technologies, and the various functionalities, including MTI radar, EA and ESM techniques, and the long-range comms. Because this system is multifunctional, it can replace multiple systems on an aircraft. So instead of having multiple systems, if you're only, say, looking forward, you just need to put this one on there. This ECM module replaces them and then also scales on the platform as well. So with this particular, the MMFA ECM, we've got it configured for a 120-degree field of view. So if you wanted to provide 360-degree, you could just take that same system, replicate it 3 times across the platform, and then there you go. You have 360 with full multifunctionality around the azimuth. The final aspect of the flexibility that we believe that converged EW provides, which is required, is to provide a foundation for a lot of these new techniques, and these new, some of them are still kind of buzzwords that get thrown around. So there's you've got cognitive and adaptive and various EW techniques which are in the works, which are of some level of development. But there's not a great definition, a great standardized definition for all of them. One of the big useful ones that we've been using is the amount of a priori information that is required to deploy that technique. And so we go from low with noise jamming all the way up to high, where you're able to actually do control. And so that requires the information on the targeted system, and you might not have that at the time. And so the final flexibility the penultimate final flexibility that we see would be needed here is the ability for this system to be wielded as a scalpel when you have the information needed to deploy those high technology, high capability techniques, but also as a hammer when you don't, and to be able to put enough jamming power, enough noise power on target to still be useful. And so this provides both of that with the high ERP through the beamforming, and then also the element level digitization, the RF FPGA, providing the flexibility to be able to deploy whatever those high information techniques are that you later develop. And this is very EW specific, but this applies to other things as well, comms, or say a new system that would work in a GPS denied environment where you wanted to have a terrestrial or an atmospheric GPS like broadcaster. Then the capability would be there because the hardware is capable and the functionality has been decoupled, and then all you really need is a software patch to enable this system to work with that new GPS denied location system. So in summary, I talked some about the context, the motivation for these converged, specifically EW systems, but ultimately working towards RF systems. The benefits of those converged systems, especially increase in the robustness of the networks in which they are apart, and then also decrease in the cycle time against adversary capability development. Talk specifically about the MMFA ECM, some of its capabilities, the hardware and the scalability, especially the element level digitization and its star capability. And then in conclusion, this is the prompt that we deigned to answer, which was that the Army requires EW systems capable of conducting EA and ES simultaneously on the same platform. We say that the solution to that is converged EW. And in the future, there'll be more acronyms up there, and the solution to that will be converged RF, because in general, the solution to increasing functionality with decreasing swap lies with converged RF systems. Thank you.
Good afternoon. I'm Herm Hasken. I'm from Markpoint Technologies. I'm going to step away from this mic a lot so I can see the slides or see them up here to check some notes. But this brief has been, our presentation has been a work in progress as much as our technologies have been as well. And I'm going to try and go through a few of those things. Why is that? Primarily because of some of the presentations you probably heard today. I'll mention a little bit of that, but also mention some of the recent documents that have come out too, and statements that were made as recent as yesterday have also been incorporated into this. So, future warfare, constantly a topic, but not just constantly a topic, but what kind? Asymmetric, hybrid, or what DARPA now is calling mosaic in the future, 2035 and beyond. We don't know if state and non-state actors have access to increasingly more advanced forms of technology. Why? Because they're stealing it. There's been a statement made by the former DERMS General Alexander about this being the single largest threat, but also the single largest theft of intellectual property in the history of humankind. And we're seeing that, and that technology is being used and being exploited to counter our technological advances or advancements, where the technology gap is continuing to shrink. So you heard the other day General Fogarty talking about the need for speed. Rapid pace, breadth, and variety of technology is having a continued impact, not just on society, but on our military and the nature of warfare. Chinese, after Desert Shield, Desert Storm, spent 8 years doing research on our technological advancements that were displayed through Desert Shield, Desert Storm. After 8 years, in 1999, they wrote on unrestricted warfare to Chinese colonels. And that was followed about 10 years later with the three warfare strategy. What's interesting in that is one of the three warfare strategies the Chinese are using is information warfare. We're hearing more and more about that, the convergence of a lot of these technologies to build a new capacity, but also new command for the Army and beyond. Need for speed. On the 9th of August of this year, the GAO just released a report. Again, you heard some of those concerns reflected, that the units in the TTP, like Multi-Domain Task Force, ICQs, and some of the other units that are out there, are being stood up but not fast enough. And on top of that, the gear that they're getting is a gear that perhaps is not applicable in a modern-day battlefield. Exord 153.17 and some R-struck memos state that the Army requires the ability to fully integrate cyber and EW and synchronize it. This has been General Milley's theme for the last 2.5 years. But what are the technologies? It's something that our company has done some research on and believe that we have a couple of solutions. That's what we're here to talk about today. Seizing the digital high ground. We all know that this is key terrain. Information is key terrain in the information environment. Insight into adversary networks, command and control nodes, and an adversary's infrastructure is CCIR for commander. That insight enables decisive maneuver, just not on the battlefield in the physical space, but in the cognitive domain as well. The intention here is to maintain that decisive decision advantage against an adversary. Insight, and again, this is insights from our research too, from our point is, we believe that insight is only going to come from persistent access. Now, I am going to give a shout out, again, yesterday, comments made by Commodore O'Sullivan from the Netherlands, talking about an unconventional approach to cyber. Well, we take a different approach to that to a certain extent. I will admit that most of our company is former soft guys, and as we call ourselves, recovering SIGINTers. We have since moved over to the cyber side and see some very practical application utilizing commercial technologies that are not defined as SIGINT. They can, in fact, be new cyber tools that can be used on the battlefield because they fall into a commander's not only his responsibility, but his authority. So insight, we believe, comes from persistent access. And again, I talked a little bit about our company and the fact that a lot of our guys come out of the soft background. We are taking an unconventional approach to this, as we've learned on the battlefield the last 18 years in unconventional warfare. That insight comes from persistent access. We believe that can become small deployable sensors. You've probably heard the term over and over again, every soldier is a sensor. We look beyond just the soldier. We're looking at every asset that's out on the field. It could be a tethered drone, an autonomous drone, an autonomous vehicle, an autonomous boat in some of the littoral areas. What we'd like to see is have those assets, any military asset that is out there, be used as a cooperative sensor. Particularly in areas where national assets are not available. We've heard of the Asia-Pacific pivot. We've heard of different areas that are now that have more national theater-level intelligence assets where there are significant gaps in collection, survey, and reconnaissance capability at the theater level. This is one of those gaps that we're trying to cover and address. Information on an adversary's mission-critical network. This is one of the main requirements that Cybercom and Army Cyber are looking at. The need for decision-dependent precision data is going to continue to grow, particularly with the onset of 5G, and I'll get to that toward the end of the slide here. We believe 5G is going to become a game changer. I know there's been a lot of discussion about it with regards to the use or leveraging 5G technologies in the U.S. Army. We also have to look at it on the other end. What are our adversaries doing utilizing 5G for A2AD strategies? And they are significant. Some terrorist organizations as well, and we can talk about that offline. So what we believe is tactical commanders must seek new capabilities and authorities for survey and recon, not just for monitoring and assessment, but for early warning, to provide critical infrastructure data for boat code planning at the theater and national level. That data is not just going to come from national assets. It's going to come from small little units all over the globe doing their military mission, again, acting as cooperative sensors while they're out forward. We also believe in habitual joint and allied training. We believe that our allies are especially important. So that's one of the other features that we took into consideration when we developed some of the technologies that I'll show you here at the end. I'm not going to go through this, but just some of the highlights here. Full spectrum cyber EW ops are best utilized in the competition phase. If you're looking at the multi-domain operations first phase, we've got to be there in the beginning, persistent access, long-term, in order to gain the insight that our commanders are looking for. It's the only way we're going to achieve and maintain information dominance in the information environment is through persistent cyber OPE or operation preparation environment. Again, just kind of addressing MDO, competition, penetration, disintegration, exploitation, and recompete. There is a key aspect and component across MDO and a role for cyber in EW in all of them. And as General Fogarty mentioned yesterday, as the command moves forward and begins to mature into an information warfare component as well. So our observations of much of what we've read, physical and virtual access via cyber OPT, or OPE, is critical to gaining insight. Passive recon and survey is an operation. It's not an intelligence activity. It seems to be still one of the biggest debates. Again, as I mentioned, self-admitted recovering SIGINTR. What we see on the Title 10 side as it relates to information operations is as it relates to cyber is we've got to be able to get more cyber or more technology in the hands of forward scouts, of reconnaissance units, of any other type of unit that is out on the forward edge that can provide the information that the commander needs to provide that standoff that we're looking for. We've got to expand the concept of persistent engagement. That persistent engagement is not only going to be done by the cyber units that the Army currently has. By the way, the GAO report mentions that they're at 20% of strength. There's got to be more thought given to more implementation of habitual partnerships with the special operations community and with our allied partners. This is just, I will say, a bumper sticker phrase here on the bottom, we all know this: technological change is constant and dynamic. We've got to be able to meet the needs because our peer adversaries are closing the gap. I'm going to go through this fast. I'm going to hit here since I've got 5 minutes left. The Army must fight in a contested, congested environment. Army service components below lack the ability to do their jobs with regards to cyber. The Army expert says, go out and get CEMA support. Develop cyber recon, survey, analysis, and C2 tools. What Markpoint has done to address this is look at a capability we call the CEMA Tactical Awareness Support Kit, or CTASK for short. CTASK main engine is Markpoint Echo with extras. What is it? It is a software-defined solution that can go on any Android-based device. It is passive in nature, and what it does is it pulls any cellular, Bluetooth, and Wi-Fi signal. We can build a larger suite of equipment that also does TPMS sensors, MZ grabbing, and a whole bunch of other signals of choice, to include doing a full spectrum RF survey, and that's the entire kit. Unlike SIGINT tools, the CEMA task can be utilized by cyber intel, SOF, LERS, DEEF, or other forward-based personnel. It is also NATO releasable. It is also Allied releasable. Because it's a software solution, it can be packaged in a wide variety of form factors integrated into existing platforms. Just real quick, and I'm going to mention this real fast, we've already had this showcased at CyberQuest. First Special Forces Group is taking it to Cyber Blitz next month, and we've also been part of several SOCOM technology experiments. And again, most of the information on here really speaks to the requirement that the Army has right now. So what is a CEMA kit? Our kit does survey, clandestine survey, which you can get to assets and get into areas that we cannot get into. Our Echo Cloud Air does data storage and flow from a tactical ground all the way up to a national big data platform. We do survey, RF survey, and multi-protocol survey, depending on the type of kit that you want. So this is essentially a handset, a laptop, a Latte Panda, or a MiFi. We can put this on a wide variety of form factors. It can be body worn, it can be vehicle mounted, or it can be put on a tethered drone or an autonomous drone. Just real quick, tactical recon to, I think I can actually use the pointer here. So we have a couple of different options here in terms of how the data can be taken from the Markpoint Echo devices with an expeditionary CEMA team, a Special Forces team out at a FOB. They're all following this adversary unit and collecting all the data, wireless data that is out there that they have associated to them. We can then cross-correlate all that data to do pattern of life, force protection, insider threat, and a whole bunch of a host of other mission profiles as well. As it says on the bottom, the CEMA Tactical Kit detects, surveys, characterizes. We do the analysis, forward-based analysis, so that the real information goes back. We have a kit that actually does the analytics and the graphic display, and then the data sharing that goes clear up the Cybercom. Okay, so what is everybody looking for next? 5G. What are we doing with 5G? So I'm not going to talk too much about this slide because most of this is still in production right now, but it will be released later this year. But our intention is to get all these devices, rather than having a recon force out forward that's looking down while they're out on a tactical mission. Everything should be heads-up display. So while you have your weapon at the ready, we're working with augmented reality through a Bluetooth connection from a body-worn device that's doing all the collection and survey to something that's actually going to show you where your bad guys are out forward. So we can see ourselves. So this actually does see red, see blue. And that's what we're trying to do, is make sure that if you're getting into close quarters combat and you know that there's a bad guy on the other side of the wall, you actually know that because you're doing your PID by virtue of the signals that are coming out of the other room. And so with that, anybody has any questions, that concludes my presentation. Sure.
On your CyberQuest data collection, the software-defined radios, do they look at certain bands of interest, or do they stare across the wide band?
You would have to ask the Cyber Battle Lab when they use the SDR. From what I understand, we have been waiting for the CyberQuest test results for 3 months now, and apparently they've only got through day 1 of the data because we collected more data. They collected more data off our devices than I think they expected that they were going to get. So it's taking them a while to get through that. One thing I'd like to point out, and thanks for bringing that up, is as a result of CyberQuest, as it's kind of a, we'll call it a authorized event, training or evaluation event. Our equipment, you mentioned earlier about the flights and everything and the storms. I failed to mention that we had the same thing. When I landed, I had a storm of emails. So apparently now all of a sudden, our gear is going out to the TACOM, CENTCOM, and UCOM AORs for operational use on some real-world missions. That was a surprise to me, but it was very good news as well that the equipment is now going through some acceptance phases and has gotten its interim ATO to be used out on the battlefield. Yes, sir.
What do you use for your analytics engine? You reference, you gather enormous amounts of data, you can transition to cloud, other things. You said you edge analytics. I'm curious what.
So our edge analytics is the analytic processing is done on the forward edge with the sensor itself. Then it goes back to a laptop configuration we call a Markpoint Echo Studio. And Echo Studio does pretty much the same thing as a EWPMT device would do or analytic capability would do. We can parse the data. We can format the data in almost, I think it's all 9 NGA accepted data formats that then can be moved over through cross-domain solutions up to national databases to collate with SIGINT databases as well. But it's our proprietary analytics software. Sir?
So that Markpoint computer is somewhere at a safe point on the edge, or is it back and forth?
Both. So what we've been able to do through using some obfuscated means of, well, we use some techniques to obfuscate the data to make it all look like HTTPS traffic. So from the handset to a secure cloud environment, using the laptop, we can then immediately turn that data around, send it back up into a cloud environment, and get it all the way back to Sanctuary. But typically, I'll say, for example, the Special Forces ODAs that are using the equipment now, they want the laptop with them out in the field. So what we've done is we've given them 2, because sometimes they do split-based operations in an ODA. You got 12 guys, 6 go one way, 6 go the other. 6 get sensors, the other 6 get sensors, but what we're doing is giving them 2 laptops so they have the ability to look at both the data. What that last Echo Warrior is going to do is going to give team view. So now I get to see if I've got split-based operations, I can see their data, they can see mine, we can share back and forth. We can also text and direct them toward different sensors that are different signals of interest that are out on the battle. Anything else? I'll be here, yes.
Is the data from the sensors pushed just over GSM, or is there another way that data is pushed? Like from the forward sensors?
All I can tell you there is based on whatever a VCT or below unit has, we can engineer or re-engineer a means by which that data can go. Okay. And I'll be in the back after that.
It might be outside. always fool